All right, now we're looking at question number 4. This is using the rational zero theorem to find out all the possible rational zeros. In the theorem, it says you're looking at the a sub 0, so here, and a sub n. A sub n is actually the coefficient of the first term, the highest power. So this is just a 1, invisible 1 here. And then a sub 0, that's this guy here, the last number, negative 8. Don't worry about the positive or negatives though, because for the theorem, it's going to take both positive and negatives. That's why you see the plus minus in the theorem. Yeah, so, okay, we're looking at now things that divide a naught. Those are the possible p values. And things that divide a sub n, those are the possible q values. So interpreting the theorem, the rational zero theorem, what it says is that your zeros have the form irrational zeros, if there are any rational zeros. And by the way, rational, that's just a word to mean it can be written as a fraction. So it includes all integers, and it includes any fractions. So rational zeros have the form p over q, where p divides a naught, that's this guy in the last number, and q divides an, that's the first number. Okay? So being more specific, that means in our case, p divides 8 and q divides 1. All right, so we're looking at things of the form p over q, where p divides 8, q divides 1. This is actually an easy one because q is 1. That makes it always just the whole number at the top, right? Okay, so let's look at the different possibilities. Let's just start with all the things that divide 8. Things that divide 8 are 1, 2, 4, and 8. So p could equal any of those numbers. Now q has to divide 1, so q is just equal to 1. That's the only possible thing it could be, right? Now for the answer then. Answer is all things of the form the p over the q. So it could be 1 over 1, 2 over 1, 4 over 1, and 8 over 1. And we get all the positives and negatives. So to indicate that, we just write a plus minus in front of each of those. Plus minus, plus minus, plus minus. Now what I have here is not really a nice form, right? 1 over 1. Why write 1 over 1 when I can write instead just 1, right? So let's just write plus or minus 1. And this one plus or minus 2, plus or minus 4, plus or minus 8. We're just reducing. Okay, so these are the different possible rational roots I could have. Very useful, right? Because now I see, instead of having to try every single possible number to figure out what my zero is going to be, I can just try these, well, eight combinations. So there's 1, 2 here, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. I don't have to experiment just wildly. I can just experiment with those particular values. Okay, that's number 4. Number 4 wasn't so bad. Let's try number 5. Number 5 is a little more difficult, but still not so bad. All right, here we go. F of x is equal to 4x to the third minus 3x squared plus 8x minus 20. Okay, so again, we're looking for things p over q, where, and I always, this kind of always throws me off a little bit, is I feel like my natural inclination is to think, okay, first number comes first, right? But just remember, it's kind of reversed. So p's are the things that divide the last number, q's are the things that divide the first number. Here, where p divides 20 and q divides 4. Okay, so what are my possible p values? P could be things that divide 20. So 1, of course, 2, 4 divides 20, 5 divides 20, 10, and also 20. Those 1, 2, 3, 4, 5, 6 possibilities. Okay, what could q be? Q could be anything that divides 4. There's 1, there's 2, and there's 4. All right, so all my factors, they're going to look at the form p over q. So what I do, just go one by one. If I stick either each of these numbers over 1, I'm just going to get the values back. So that means P or Q could be, well, let me just write the possibilities in black. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Those are the values over 1. Then do the same thing for 2. So 1 over 2, plus or minus a half, plus or minus, next is going to be 2 over 2, but 2 over 2 is actually equal to 1, right? I already have 1, so I'm going to skip that one. But you know, actually, just to make it more simple, I'm going to not skip it for now. I'll just cross it out after. So 2 over 2, 4 over 2, plus or minus 5 over 2, plus or minus 10 over 2, plus or minus 20 over 2. Okay, they do the same thing for the last one. So plus or minus 1 over 4, plus or minus 2 over 4, plus or minus 4 over 4, plus or minus 5 over 4, plus or minus 10 over 4, and plus or minus 20 over 4. So these are all the different possibilities I could have. The only thing is I have some duplication here, right? The first row, there's no duplicates because those are all just whole numbers, right? I'm going to look for duplicates after that. 1/2, that has not appeared yet. 2 over 2, that's equal to 1. So I don't need that guy. 4 over 2, that's equal to 2. I already have that, so I can take that out. 5 over 2, that's new. 10 over 2, that's actually 5, right? And I had 5 here. So cross that guy out. 20 over 2 is 10. I had 10, cross that guy out. 1/4, that's new. 2/4, that's actually a half. We already have a half, so cross that guy out. 4 over 4 is a 1, cross that out. 5 over 4, that's new. 10 over 4, that's actually 5 over 2 if I reduce it, right? So I had that one already. Divide this will be 20 divided by 4 is 5. This is equal to 5, so I already have 5. Right, that means my possible rational roots are all the guys that are remaining. Plus or minus 1, 2, 4, 5, 10, 20, and 1/2, 5 halves, 1/4, and 5/4. That's it. So if I want to check what my actual roots are, these are the only ones I needed to check. Alright guys, that is numbers 4 and 5. So we'll stop here and then I'll show you the last two.